Hi guys, so for today we're going to talk about vector addition of forces, sample problems, and we're going to solve some problems including forces in two-dimensional. Right, so let's get started. So for number one, we have a simple illustration or figure here. For number one, we are going to resolve F1 into the components along the U and V axis and determine the magnitude of these components. So in other words, this force F sub 1, we're going to resolve it into the u-axis and v-axis and get the magnitude of these components. So as we all know, we can project this F1, okay? We can always project this F1 in our v-axis. This would be our F1v, okay? And to our u-axis, okay? Such that this would be our F1u. Okay? So, as we can see, if they meet at the same common point, this is the origin of our problem. So, if I'm going to move this F1b such that this should become our F1v, that is still F1v because we can freely move vectors. We have moved the vector from, okay, from this position to this position because we can freely move vectors. And as we can see, if we are going to get the magnitude or the resultant of this vector, this would be the vector, okay? Because it's drawn from the very first tail up to the last arrowhead, which is this. So this is our F1, obviously. And if we're going to get the F1u and F1v here, well, of course, we need to get the angles inside of this triangle. Okay? So, let me make this clear. This is our triangle, and we can use sine law in getting the components of F1u and F1v here. Okay? So, how do we do that? We need to get the angle here. Okay? And we need to get the angle here. So, of course, we are given an angle of 105 here. If I'm going to extend F1b such that this is extended to here, okay, up to here. So as you can see, this 105 angle will be the same by this because they are vertical angles and vertical angles would be congruent. I don't know if that vertical angle is correct term, but this angle should be the same as this because technically speaking, this is also F1b. And this is F1b, this is F1b, this has a 105 degrees angle, then therefore it's vertical from the axis, so this should be 105 degrees also. So if I'm going to redraw it, such that we can actually visualize it more, this is our F1. This is 30 degrees. Okay. This is our F1V. This is our F1U. Okay. Such that we extend this F1B because technically speaking, we have an angle here of 105. Okay. And technically, the angle here should be 105 also. Okay, by trigonometry. Okay, if this is 105, this is 30 degrees. We know that the sum of the triangles, okay, the sides or the angles of the triangles is 180. 105 plus 30 is 135. So 180 minus 135, this should be 45. Okay? And we are now ready to get the components F1b and F1u. Okay? By simply knowing this angle and by simply moving this F1b in this position. Okay? So what will happen here is that if we're going to use sine law, okay? So for example, I'm going to use sine law, sine of 30 degrees, okay? Over, this is the sine, this is 30 degrees. What is its opposite? This is F1b, okay? Is now equal to, I'm going to use sine 105 over, this is 105, its opposite is the F1. So this is F1. So upon knowing this, let me just rewrite this. Okay, we have sine of 30 degrees over F1V is equal to sine 105 over F1. Okay? So we are after the F1V. If we are after the F1V, we can reciprocate this such that we have this formula. Okay? So if I'm going to solve for F1V, that should be F1V is equal to F1 sine 30 degrees over sine 105 degrees. And our F1V is equal now to the first one, which is this, 250 newtons, 250 newtons sine 30 degrees over sine 105 degrees. So we are going to solve that. We would find out that our solution, and make sure that your calculator is in degree mode, not in radians. So we have 129 newtons. Okay? 129 newtons. So we have solved for the magnitude of the component of this F1V. How about the F1U? For F1U, we would simply, by sine log n, this is sine law, okay? For F1V, we use this. For F1U, okay, we can use sine 45 degrees. This is our 45 degrees. Opposite is F1U. And we can use still the same, sine 105 over F1. So, if we're going to solve that, again, let me just rewrite. Sine 45 over F1U is equal now to sine 105 over F1. Okay? And if we're going to solve for F1U, it turns out that this is F1U over sine 45. Okay? F1 over sine 105. So, what will happen? F1U would be F1 sine 45 over sine 105. So, F1 again is 250 newtons sine of 45 over sine 105. And if we're going to solve that, okay, better if you have calculator with you because this is statics. So whenever you're trying to solve something, better to have your calculator always beside you. Okay, so we have 183 newtons. Okay, so that is the magnitude of the components of F1V and F1U of the force F1, 250 newtons. So this should be our final answer, 129 newtons and 183 newtons for F1V and F1U. Okay, so how about for number 2, we are asked to resolve the component the same, F2 into components along the U and V axis and determine the magnitude of these components. So, if this is our F2, okay, I'm going to project it here. We will be having what? An F2 here. F2, okay? This is our F2V, okay? Along in this direction. And of course, this is our F2U in this direction. Okay. So, again, we can use the sine law, okay, in determining the magnitude of the F2V and F2U. So what will we do again? So we're going to determine once and again the angles. Okay, this is our 30 degrees. Okay, let me just rewrite it. This is our F2V. This is our F2U. Okay, and this is our F2. F2, F2V, and this is our F2U. And as you can see here, this is, let's say, this would be our V axis. Forgive me for my drawing, but it's still the same. So we have, this is our U axis. Okay? And this angle, they say, according to the given, this is 105 degrees. So if we are going to get this angle, okay, if we're going to get this angle is 75 degrees because this is a straight horizontal line, the angle should be 180. If this is 105, this is 75. Obviously. And if we're going to extend F2B in this direction, this F2B is the same as this. And if we're going to extend this is 75 degrees, okay? This is 75 degrees, so this should be 75 degrees because vertical angles are congruent. And take note that this is 30 degrees. This is given, okay? This is 30 degrees here, 30 degrees. And how about this? Again, 75 plus 30, that is 105. And the sum of all the triangles, the angles of triangles is 180. So if this is 105, 75 plus 30, then this angle should be 180 minus 105, which is also a 75 degrees. So if we're going to redraw the triangle now, we have this F2V and we have this drawing. So we have this F2, which is 150 newtons. We have this 75 degrees. This is also 75 degrees. And this is also 30 degrees. This is F2V. This is, again, F2U. So what will happen by sine law? By sine law again, we'll be using, first, of course, we know the F2. We can use F2 over sine 75. Okay? This is also the same as sine 75 over F2. Just be consistent. Okay? So if you put this on the numerator, then definitely you will put a numerator also here in terms of the F2, not the sine. Okay? So we have F2 over sine 75 and we need to get, let's get F2V. Okay? F2V, this is our F2V over sine 30 degrees. So if we get F2V here, so what will happen? This turns out to be F sub 2 sine of 30 degrees over sine of 75 degrees. Okay? So if we're going to substitute, F2 is 150, so 150 newtons sine 30 degrees over sine 75 degrees. Okay? That should be 77.6 Newton or 78 newtons. Okay, how do we get F2U? The same principle. Okay, F2 is over sine 75 degrees is equal now to F2. Here is our F2, F2U. Okay, the angle opposite to this is 75, so this should be sine 75 degrees also. And as you can see here, okay, we're going to write this, F2 is now equal to F2U sine 75 degrees over sine 75 degrees. These two would cancel. So you are leaving with an answer that F2 is equals to F2U, which means that F2U is simply 150 newtons. So we have solved the first two problems by actually using our knowledge in trigonometry only. Okay? And by the knowledge of our vectors, we can move the vectors freely. Okay? And I hope you can follow in our discussion. So this is our answer for number 1 and 2. So let's go now for problem number 3, I guess. Okay? So for problem number 3, so determine the magnitude of the resultant force F sub r, F1 plus F2 and its direction measured counterclockwise from the positive x-axis. Measured counterclockwise, meaning from here to here, counterclockwise. So clockwise is in this direction. So counterclockwise is this, CCW. Clockwise is this. Okay? So we will be finding the resultant force of this given two vectors in here, F1 and F2. Okay? So, I'll be using the component method. So, we have, if this is 30 degrees with respect to y, we know that the angle between x and y is 90. If this is 30, this should be Okay, this should be 60 degrees. Okay, if I'm going to solve that, let me change my color. By components, I can get f1x and f1y. F1 with regards to x, or component of f1 in x, component of f2 in y. And I will be using the formula f1 cosine theta and f1 sine theta. And what is again the theta? The theta is the measurement of the angle with respect to the positive x-axis. Okay? So, with respect to the x-axis. So, F1 is our 250 cosine with respect to x-axis, that is 60 degrees. We have 250 sine 60 degrees here. Okay? This turns out to be 125 pounds. Okay, and this is 216.51 pounds, not newtons, pounds. Okay, 216.51 pounds. Okay, so that is our F1x and F1y. We're going to get now the F2x and F2y here. Okay, so as you can see here, F2y is actually 45 degrees, okay, away from its angle from x, measured, well, of course, clockwise. Okay, so f2x, in order for us to resolve f2x, we need to have f2 cosine theta and f2 sine theta. And of course, f2 is 375 cosine. Okay, cosine, this is, okay, measured clockwise. Okay, clockwise from the x-axis. Cosine 45, so that should be negative because you are measuring it clockwise. Okay, we measured the 60 degrees here as counterclockwise. Okay, so that if it is measured from the x-axis for clockwise direction, that should be negative 45 degrees. Okay? And it is evident if we're going to resolve f2 into x component and into y component, that we will be having a value that is positive x and negative y. So we have cosine negative 45. That should be 265.17 pounds. And we have 375 sine of negative 45 degrees. We have negative 265.17 pounds. Okay? As you can see here, you can use 45 degrees. Okay? It's okay. If you use 375 cosine 45 degrees, that's okay. But after that, you're going to include whether your result is positive or negative because this F2 has a direction. So if you did not include negative here, for example, 375 sine 45 would bring you a positive 265.17, which is wrong. Why? Because this F2, if you're going to resolve it into its y component, this would be the F2y. And it's going down, so it should be negative. So that's the danger of not using the negative. You might forget to include the direction. Okay? But if you're going to strictly follow this, the answer or the problem, okay, the answer that you will get is automatic. This negative means that it's going down. Okay? So, what are we going to do? Summation of f of x, summation of f of y. If we have f1x plus f2x here, and we have f2x plus f2y, f1y, I mean, okay, f1y. So I have f1y plus f2y here. So if we're going to do that, f1x is 125, f2x is plus 265.17, we have a 390.17 pounds. Okay? And F1Y, if we're going to do this, 216.51. Okay, F2Y is plus negative 265.17 pounds. So let me not just include the pounds on the final answer. Okay, 17. So that should be negative 48.66 pounds. Okay? And what do we do in order for us to get FR? Okay? The FR is actually the summation, okay, square root of the summation of f of x squared plus summation of f1y squared. So that would be 390.17, okay, squared plus negative 48.66 squared. And our resultant force in terms of its magnitude is 393, okay, 393.12 or 192 newtons. 192 or 192 pounds, I mean. Okay? So this would be pounds. Okay. How do we get the direction of this? So we have theta, arctan, of the summation of f of y over summation of f of x. And as you can see here, arctan, what is our summation of f of y? That is negative 48.66 over 390.7 pounds. So we have 7.11 degrees. Negative 7.11 degrees. Let me just rewrite. Okay. Negative 7.11 degrees. That is our direction. Okay. But negative 7.11 degrees suggests that, okay, if we have the x and y axis here, then the direction of our, let's say, let me draw this exaggeratedly, okay? So, it means that our FR, okay, this is our FR, let's say, FR is negative 7.11 clockwise, okay, measured clockwise on the positive x-axis. Whereas the problem is actually asking us what is its angle or direction in the counterclockwise direction. So what are we going to do? This negative 1711 theta, okay, 7.11 degrees, we will be adding plus 360 degrees in order for us to get this angle, okay, counterclockwise with respect to x. So what will happen? We have plus 360 degrees in here. So negative 7.11 plus 360 is 300, of course, 352.89 degrees. So this would be our answer. 352.89 degrees, that is the direction of the resultant force F sub R. And the magnitude of the F sub R is 393.19 pounds. So let's continue for problem number, let's say, 4 and 5. Okay? So, determine the magnitude of the resultant force F sub R in this given figure and its direction measured clockwise from the positive U axis. Okay? And for number 5, that is resolve the forces. Okay? Resolve the forces F sub 1, F2 into components acting along the U and V axis and determine the magnitudes of the components. So for this problem, I'm going to use again the component method. For me, it's much easier, but you can also use some methods like the cosine law. Okay? So if I'm going to redraw this such that I'm going to replace this by a single point, okay, this would be this. So what will happen is I'm going first to get the resolution of these two vectors in order for me to get the resultant force F sub R. So I need to complete the angles. Okay? So, now, here is the translated, simplified, let's say, diagram of the problem. So, the problem is, if I'm going to get F, okay, F1, let's say, U, okay, and F1, V, okay, so what will happen here is that I'm going to get, oh, okay, so there's no problem in terms of F1 because I know the angle with respect to the positive U axis, okay? So if I'm going to get F1U, I'm going to get F1 cosine, since this is measured, okay, measured counterclockwise, okay, or clockwise from DU, I will label this as negative 30 degrees. Okay, and I have F1 the same, sine negative 30 degrees. And what will happen? F1 cosine, which is 300 cosine negative 30, would yield 259.81 newtons. And F1, 300 sine negative 30, that would yield to negative 150 newtons. So, what I'm going to solve again? So, we need to resolve F2U and F2V in order for us to get the components, the components, and definitely get the F sub R. Okay? I use negative 30 here again because it is measured negative 30 clockwise from the U. Okay? And but for the final answer, we can get the positive degree because it says here that this indication, whether clockwise or counterclockwise, we're going to use 30 degrees. Okay? In the final answer. Okay, but in terms of resolution, you must strictly follow this. Okay, so the problem is, if we're going to get F2U, resolve this F2 in terms of U and in terms of V, okay, in terms of U and V, we don't know the angle of this F2 with respect to this U. Okay, so if I'm going to extend this, okay, such that this would be the extension of this force, we can see that this angle, by vertical angles, this would be 45 degrees. And as you can see also, okay, that this V, this straight line V has an 180 degrees. And I have an angle of 45 and 70 here. So if I'm going to add this 70 plus 45, 70 plus 45, okay, that should be 115. And I know that the angle of this, since this is the axis, that is 180. So, if the angle combined by 70 degrees and 45 degrees is 115, so this angle should be 180 minus 115 degrees, which is the combination of 70 and 45. So 180 minus 115, that would be 65 degrees. Okay? And as you can see also that this should be 65 degrees because this is vertical angles. Okay? And my problem is now solved. Okay? I can use 65 plus 45 plus 70 plus 65 to get the F2 cosine of that theta. Okay? Because this theta is measured from the positive U. Okay? So that would be, let's say, for F2U, we have F2 which is 500 newtons. 500 newtons cosine of the 65 plus 45 plus 70 plus 65, that is cosine of 245. We're going to get that 500 cosine of 245, that should be negative 211.31 newtons. And the same for F2V, that is 500 newtons cosine or sine, sine 245, that is 500 sine 245, we have negative 453. Negative 453.15 newtons. So this is our F2U, F2B. And what are we going to do to get the FR? Okay? So the FR is simply F1 plus F2. Okay? The summation of F1 and F2. So if I'm going to get the summation of U, okay? Forces at FU, FU 1U is 259 point, okay? 259.81 newtons. F2U is minus 211.31 newtons. So if I'm going to perform that 259.81 minus 211.31, that is 48.5 newtons. And again, summation of FV. A while ago, this is X and Y. While ago, this is X and Y, but in terms of our example, that is the axis of U and V. So that is still the same, okay? So for summation of the forces along the V axis, we have negative 150 newtons, okay? Plus this, okay? Negative 453.15 newtons. So they would be result into negative 603.15 newtons. If we're going to get the FR, okay, our FR is the magnitude of the summation of f of x. I'm sorry, not f of x, f of u squared plus the summation of fv squared. So what will happen here is that 48.5 squared plus a negative 603.15 squared. So the result is 605.1 Newton. So that is our resultant force. And the direction of our resultant force, arctan, okay, summation of F of, in terms of V, this is our Y, and in terms of U. Okay, so what will happen? Arctan of the summation of negative 603.15 over 48.5, and that result to a negative 85.4 degrees direction. So this is negative, so it means that the direction of our FR, let's say that this would be our FR, the angle with respect clockwise, okay, clockwise to our U, positive U, would be negative 85.4 degrees. But if we wish, again, to get the direction also in this direction, we can drop out the negative sign and we can have 85.4 degrees direction as our FR. Okay? So, it's still the same, okay? But in mechanics, sometimes the negative does not matter, I think, because it's for physics, this negative is for physics, but still, we can have these answers, okay? So, we have 85.4 degrees. But the more precise, if I'm going to use this notation such that it doesn't matter whether clockwise, whether measured by clockwise or counterclockwise, the result is 85.4 degrees. So that should be the direction of our resultant force. And of course, the problem is actually asking us measured clockwise. So if it is measured clockwise, then definitely this angle would be positive because its reference, it states that if we measure it clockwise, then the angle should be positive. So the result should be 85.4 degrees. So let's go now to number 6, problem number 6. Okay, let's try. The force acting on the gear tooth is F is equals to 20 pounds. Resolve this force into two components acting along the lines AA and BB. Okay, we're going to resolve this force in the line AA and BB. So, it is tantamount if I'm going to say that this force we can redraw this force for easier illustration or for easier calculation as this. This is my force, okay? So, I've actually transferred this force onto this force. This is still the same force as long as I do not change the magnitude and the direction of the force, okay? And as you can see here, if this is my force, okay, this angle should be 80 degrees and this angle should be 60 degrees. Okay, agree or not? Because that is vertical angles. Okay, this is 80 degrees because of this, 60 degrees because of this. Vertical angles are congruent. And if I'm going to say, let's say, this AA is a slanted line, but technically, if we measure this angle from this angle, okay, what I'm trying to say is that we have, let's say we have a straight line. This is our AA, okay. If I'm going to measure the angle, that is 180 degrees. So, if this is 60 degrees, if this is 80 degrees, 140 degrees. So, what is this angle? 140, okay. Since this is 180, 180 minus 140, that is 40 degrees. Okay, why did I get that? Because it's important, because we're going to resolve F in terms of A and in terms of B. Okay, so if I'm going to resolve this force F into A, I would be having an FA here. Okay, and into B, I will be having FB here. Okay, so if I'm going to draw that, let me just really try my best, though I'm not really good at drawing. Okay, so this would be our FB. Okay, this is our FB, F sub B, and this is our F now. Okay, our F, this is the projection of F into A. So such that if I am going now, what? To move this FB in here, it's okay. Okay? This FB is the same as FB here. So what will happen? Okay? If you remember, this is 60 degrees. Okay? This is 60 degrees. And the distance of this, the angle of this is 80 degrees. So, if this is 80 degrees, this is the same FB as this, then this should be also 80 degrees because it is opposite, okay? Opposite angles or vertical angles, again, opposite angles are congruent. So, this is 80, this is 80 because that is the same FB. Okay, and I hope you get what I'm trying to say. It's geometry. It's actually trigonometry. Okay, so 60 plus 80 is 140. We know the sum of this triangle is 180. So this should be again 40 degrees, which is equivalent also to this. So we have drawn now the triangle. So for simplification, I'm going to delete this. Okay, this is now our triangle, such that by sine law, again, by sine law, if I am going to find F sub A and F sub B here, because that's what we want, okay? I can use FA over the angle opposite to this is 80 sine 80 degrees is equal now to F. This is my F, okay? Let me just rewrite this. This is our F, our given 20 pounds, okay? That is our F. So F over the angle opposite to this is sine 40 degrees. Now, tell me, can I get FA? Yes. So you can get FA by F sine 80 degrees. Oops, let me just rewrite. Sine 80 degrees over sine 40 degrees. And F is equivalent to 20 sine 80 degrees over sine 40 degrees. So 20 sine 80 over sine 40, that is 30.64 pounds. Okay? That is our answer for resolving that force along the line AA. Along the line B, okay, by sine law again, can use F of B Okay? The angle opposite to this is sine 60 degrees, equivalent to F over sine 40 degrees. So, if I'm going to get FB, that should be simple. That should be F sine 60 degrees over sine 40 degrees. It's equivalent now to 20. It's still 20 sine 60 degrees over sine 40 degrees. I hope you are not being bored because I solved this as a step-by-step process. Okay? So, if we solve this, 26.9 pounds. Let me just recheck. 20 sine 60 over sine 40. That should be 26.9 pounds. Okay? Or 95. If you have two decimals. So 26.95 pounds. 26.95 pounds, or simply 26.9. Okay? So that is it. That is our answer. So that is our answer for this problem. And I would like you to work with some problems. Okay? Okay, this problem. I'd like you to work on this problem. And if you have time, please comment down below your answers or your answer. And then I'll be posting the answer once I get many answers in the comment section below. So, thank you so much. This is Engineer Abat. Again, I hope you learned something today from our discussion. Thank you so much and God bless.